thank you all for those who have continued to join. We're going to give just a couple more minutes so folks can join, and then we will be kicking off the actual presentation. So one moment and we'll be started shortly. Hello, everyone, and welcome to the webinar. We are going to go ahead and get this kicked off. So thank you all for joining. Really appreciate it. You spending your lunch hour for some of you, morning or afternoon for others. And we will also make this webinar available as a recording afterwards. So if there's something of interest, you will be able to come back and take a look at that on Teknion's website. So thank you for joining again. Let me introduce our topic today. We will be covering data warehouse migration to the cloud, and particularly focusing on how we can power that with WhereScape and Snowflake, two of Teknion's partners. So we're excited about that, and we are going to have a special guest join us today. So I'd like to do a couple of introductions. My name is Jonathan Agee. I am one of the practice leaders at Teknion Data Solutions, and I'm also the partner manager for our WhereScape and Snowflake partnerships. And so very excited to be able to lead this webinar and share some exciting information with you all. We are joined by Michael Tantrum from WhereScape. He is the Director of Alliances at WhereScape and has been around WhereScape for a long time, using the tools, doing implementations, and sharing the value of automation with many companies. So thank you, Michael, for joining us, and welcome.
Thank you, Jonathan.
All right. So what I want to do is I want to spend a little bit of time taking you through some background information on these two key technologies that we're going to be talking about today. We're going to start with Snowflake. And Snowflake is not necessarily a household name, but it may be something that many of you have come across. And so I'm going to pose the question here: why are people migrating their data warehouses to Snowflake? And particularly want to answer that by starting off with Snowflake is the first ever data warehouse database platform that was built specifically to take advantage of the cloud and all that comes with the cloud in terms of scalability, in terms of elasticity, and so on and so forth. And so we're really excited about Snowflake, and we are seeing massive excitement in the marketplace around Snowflake, both from an investment standpoint in the company and from a customer standpoint in terms of adoption and excitement in the market. So that's why we're talking about Snowflake today. So kind of to get at why, the behind the scenes why of people looking at Snowflake, and why is it revolutionary? What's so different about it? At the end of the day, you've got these several differentiators. One, we can bring in any type of data, and that's something that several database platforms allow. But we have instant and unlimited scalability. And that means that we can scale up or scale out our resources on demand. Literally can happen with no programming. It can happen completely in an automated way by the platform. Zero management burden. Snowflake is truly a service, and so it does not require nearly the level of DBA support that other platforms require. We have some revolutionary capabilities in terms of live data sharing, where a company can make data as an asset something that they can share with either customers or partners, and do that with no data movement, simply by granting access to it. Underlying all of that is a unique architecture that separates truly compute from storage, and so it lets you pay for only what you use. So I like to think of these kind of boiled down into three key areas about why are people migrating to Snowflake. One is cost, that you pay only for what you use, so you have a truly optimized cost structure. Secondly, is another cost element, and that is that it takes less effort to implement and manage Snowflake, so that addressing that management burden. And finally is performance and concurrency. So we are able to support larger workloads and do them in a much more concurrent way across many different user bases. So those are that's the background on Snowflake. Today's call is not primarily about Snowflake. Snowflake is driving the reason for this call. And so what I'd like to do is I'd like to hand it over to Michael to give us a little bit of background on WhereScape and the capabilities of WhereScape, and then we'll dive into the topic of migration specifically. So Michael, take it away.
Thanks, Jonathan. So at WhereScape, our heritage is about automation, and automation in the data space. And so we started in the late 90s, as a lot of companies do, as a data warehouse consulting firm. And very quickly we realized there was a lot of repetitive manual work that we were doing when we were creating data warehouses for people, creating tables, stored procedures, copy and paste of previous ones we'd done. And we realized there was a lot of pattern-based work we were doing, and it was ripe for automating. And so we wrote a piece of software which we had for internal use, which was our secret sauce to make us better than all the other consultants. A customer saw it in 2001 and said, could they buy it? And that's when the beginning of the WhereScape software products were born. So we consider, when we look at automation in the, we say data infrastructure because it's not anymore just a data warehouse. We say data warehouse, data mart, data lake, data vault, data store, whatever your data infrastructure looks like, analytic data infrastructure looks like. There are many facets that we consider are ripe for automation and that we do indeed automate. So we talk about design automation. How am I able to look at a source system and come up with a design programmatically? Development automation. How do I physically build my end structures, so database tables classically, and the processing to populate that? Deployment automation. How do I keep my development, my test, my QA, my production in sync in a governable and auditable way? Documentation automation, absolutely critical. As I build rapidly my data warehouse environment, I need to have all of my documentation automatically generated and automatically up to date. Lineage, impact analysis, data dictionaries, etc. And finally, daily operations. How do I operate this thing that I have built in a way that is repeatable, that is fail-proof, and keeps my data warehouse fresh? So those are the five, what we call the 5 Ds of automation in the WhereScape world. Okay, so we have 2 primary products, WhereScape 3D and WhereScape Red. WhereScape 3D is a tool which tends to be source focused. Go point at a source system and tell me about that system. So go discover the the physical structures, so go query system catalogs, tell me about what tables are there, what views are there, what columns, data types, nullable flags, etc. Foreign key relationships, primary indexes, primary keys, and things like that. So it's about firstly discovering. Secondly, it's about profiling. Look at the data within those structures that we have discovered, profile it, and tell me about that data. Now, anybody who's developed a data warehouse does this manually. Typically, they write 1,000 little queries where they look for uniqueness in a column, they look for, try to determine a data type of a column, they try to determine how the data is distributed. So profiling is something that we can automatically do with 3D. We can also do design automation here, and this is for if you are using a very pattern-based design, and a very good example of that might be something like a data vault. Then we can also automatically generate out a data vault. And we can apply design standards, things like adding, things like surrogate keys and system columns and things like that. And we can also document that source. So 3D, data-driven design, and this is about source focused. So that's our first product. Our second product is WhereScape Red. And WhereScape Red is the build and operate tool. So this is where we would build out in the Snowflake world, we would build out your Snowflake tables, your Snowflake views, Snowflake code blocks to transform data, variety of Snowflake scripting to acquire data from outside of the data warehouse. And so you can see that picture on the screen there. It kind of lays out the architecture of how we would build in WhereScape Red. We'd acquire data from the source, and we would generate native, in this case, native Snowflake objects. WhereScape Red is also operates on, I think, 16 different target platforms. So your very traditional SQL Server, Oracle, Teradata, Netezza kind of platforms. Things like Hive on the big data space, and some other cloud databases as well. But what we're finding is customers most recently are having excellent success with Snowflake as a target for the reasons that Jonathan said, the ultimate breathe in, breathe out scalability. Okay, so WhereScape Red is going to build your native Snowflake structures as we go. It is an ELT tool. It is very light in terms of architecture. Very light in terms of architecture, and it contains, does not require its own server. It's going to operate essentially on top of your Snowflake architecture. Okay, and we'll talk about
very good, and thank you. I think you've given us a great background on WhereScape and the automation there. At the end of the day, what we see folks using WhereScape for is rapidly speeding up the development cycle, and that has been what the legacy that WhereScape has brought, and why we've brought that to the table to many of our customers building data warehouses, is that this automation platform, 3D and Red, lets us build data warehouses in literally a fraction of the time that traditional technologies would let you do, because of the core value of automation, capturing everything in metadata and leveraging that metadata to generate all of these objects. So that then leads us into the core discussion of this webinar, and that is, what does it look like to migrate, and how do we start applying these automation techniques to migration. So what we'd like to do is take a look at the anatomy of a migration project. What are the pieces of that project that you have to tackle with or without automation? And then we'll talk a little bit about how how we've got some approaches for that with WhereScape and Snowflake and other things. So this slide really helps sum it up in that we have three primary areas that we here at Teknion look at a migration project and have to focus on. First off is we have to get the actual data warehouse moved into the cloud, moved into Snowflake, and we can do that with kind of a lift and shift approach. And this is a little different than I think legacy projects have been, where you've typically been doing more of a new build for a new platform. If you re-platform your data warehouse, you often aren't going to just try to copy and migrate. But I think the value that Snowflake is bringing is driving a lot of people to want to take advantage of that very quickly. And so we are seeing folks really look at how do I lift and shift my current data warehouse to the cloud. So we're going to talk about how WhereScape's automation technology can be applied to that specifically in a moment. The second area is you have to look at and either redirect or re-architect your data pipeline. How is my data populated into my data warehouse? And then subsequently, how is it shaped once it's in my data warehouse into the structures that my end users are generating value from, right? So into my facts, my dimensions, my data stores, that data vault structure that we want to keep our long-term store of data, whatever that is for you. That part of the process often has to be revisited when we re-platform the data warehouse. And so we'll talk a little bit more about why that is and some of the elements of what a cloud architecture looks like mean that we have to ask hard questions, right? Should I do transformation inside the database or outside the database? Kind of that classic ETL versus ELT discussion. And so Michael's going to tell us a little bit more about how WhereScape tools can be leveraged to really do the right thing in terms of reevaluating your architecture and getting there quickly. So we're going to talk about that. The third area is a really big area that has to be addressed, and that is redirecting our BI tools and our users to leverage now the database that's in our data warehouse that is in the cloud. And so depending on every customer's environment, this can be a very different type of project. Depends on the tools that are in use. It depends on the nature of many of those interactions, whether the users are accessing it directly, whether the BI tool that you have in use already supports Snowflake or doesn't, and how much of a metadata layer has been built out in your environment. Those various different factors are going to influence how big or small this project is, and that's something that unfortunately we don't have a one-size-fits-all. Probably fortunately, actually, but there's no one-size-fits-all for this, and so that's something that we would love to have a conversation about if you're looking at a migration project. And Teknion has deep expertise in a variety of BI tools, and we can definitely help out with a strategy around how to approach this redirection of them and training of users. One thing that I will say is that most of the modern BI tools that folks are using do support Snowflake, and Snowflake itself is very robust in terms of supporting diverse types of SQL. And so we see that there's often very little impact to the actual queries and from a development perspective. So that's a good thing for most folks. So Michael, I'd like to turn us back to the first two of these and pose the question to you. Tell us a little bit about how WhereScape is addressing this challenge for clients of first lifting and shifting the data warehouse to Snowflake, and then secondly, the challenge of re-architecting their data pipeline to work with Snowflake.
Yeah, very, very good questions. And so when clients who have reasonably mature warehouses on traditional platforms, one of the classic things they get to is, we're starting to reach capacity problems or scalability problems, or maybe access to our user community. And so they say, look, we've got 10,000, 50,000 database tables in our data warehouse. That's an awful lot to move to the Snowflake. If I have to have a human being look at each table and write some DDL, to create the table in Snowflake, and then I have to write a script to move the data across. Multiply that by even 500 tables is an awful lot of effort for an awful lot of people. And so the migration effort of how do I get from a traditional warehouse into something like Snowflake is often a big barrier to considering moving to a cloud strategy, which is sad because Snowflake is built from the ground up for this beautiful multi-user performance. So what the WhereScape approach is to say is, well, and in fact, Snowflake came to us and they said, this is a problem we're striking a lot with our customers. They say, we love this, sexy new database. It's a great thing, but if only you'd been here 5 years ago when we were starting our data warehouse project, could you help us migrate? And we said, well, we have the components in place, WhereScape Red and WhereScape 3D. And so let's see what we can do. We have the ability to look at your legacy warehouse. Let's say it's SQL Server or Teradata. We can programmatically discover the structure of what you have. We can create the Snowflake equivalent. And we can generate all the scripts to move the data. So that first piece of lift and shift, instead of having a human having to check every single table of 10,000 tables, we can say do it once and apply that pattern to all 10,000. Gets a little more complicated than that because sometimes you have massive tables, multi-billion row tables. You can't move those in a single transaction, and we'll cover that through in a bit of a demo a little later in the webinar, but all of those sort of considerations have to be taken into account. And so the lift and shift aspect of migrating a warehouse is something that we can do automatically. Now the second part of that is the re-architecting the data pipeline. Now this is fraught with difficulty because almost always your data pipelines have been written manually. Even if you've used tooling to do it, it's still someone has manually crafted a data stage workflow, or they've handwritten a Teradata stored procedure, or there are some form of manual intervention. So being able to automatically reverse engineer code and create the Snowflake equivalent is very difficult. So a human being still has to look at that. But what we can do is once we know what it's doing, we can use the WhereScape automation to generate automatically what the new data pipeline would look like. Now, part of the problem is your old data pipeline was optimized for your old technology. You did a whole lot of very clever work to optimize for performance and statistics and indexing and partitioning and all of those things which mattered with your old technology. On Snowflake, you've got a new set of architecture with a new set of performance tuning and things like that. And so while you could take a very simplistic approach to repoint a ETL tool at Snowflake, you really want to take advantage of the new architecture and rebuild it. So using WhereScape Red, because we automatically will generate the code for you and generate the table structures for you, it allows for very, very fast, very agile development of your data pipelines there. We've done some very interesting projects with Teknion around this, and we've seen some dramatic examples, and we'll see one here, Aptus Health. This is a healthcare company based over on the East Coast, and these guys were actually they're a data vault as their modeling technology, and they said, look, we love the Snowflake thing, but how do we actually get work done? We've got a huge amount of work to get through. We already we know we want to do data vault. We can't easily come up with a model, and so you can see the quote on the screen here from Peter Nilsson, and he basically said using automation we were able to automatically generate the model, automatically generate the structures, and it saved literally thousands of engineering hours. So if you think there's 2,000 engineering man hours in a year, saving multi-man years of effort is what they said. So their thing was moving from SQL Server to Snowflake. And they used the WhereScape automation to generate out their data vault model, build their Snowflake structures. They had their first data vault up and running in 3 days, and the first one in production in 3 months. So anybody who's ever built anything like this will know that typically this is a 12 to 24 month project, and these guys were able to do it in a quarter of the time with a significantly smaller team size than they would have otherwise.
So that's the value of automation coming into play there. And so Now what we want to do is take a look at specifically Migration Express that tackles that first part of the problem that we mentioned of lifting and shifting the data warehouse into the cloud. And so for that, I am going to pass the presenter role over to Michael, and he is going to walk us through a detailed demo of Migration Express. We will have questions at the end of the webinar. So if you have questions as we go through, feel free to post them in the webinar so that we can address them, and we will come back around to them at the end. So Michael, I think we can see your screen now. You are all set to go.
Excellent. Okay, so my scenario is going to be someone who has a SQL Server warehouse, legacy warehouse, and they want to move that into Snowflake. So we've already talked about the two components, WhereScape Red and WhereScape 3D. I'm going to start on WhereScape 3D, and I'm going to, we've connected to my SQL Server warehouse here, and you can see I have multiple schemas in my SQL Server warehouse, and I have one here called Dev SalesMart. So what I want to do is to discover this Dev SalesMart to find out what objects are in there and then create the Snowflake equivalent. So I will start by discovering my warehouse, and what this will do is it's going to run a series of queries against the system catalog, and it's going to say, tell me what table structures are there, what are they called, and then what columns are there, what database attributes, what data type attributes are there, and such. So it's a relatively small schema, but it's for demonstration purposes it works well. So it's gone off and it's run some queries, and it said I have discovered that there are 1, 2, 3, 4, 5, 6 tables here. There seems to be a fact table, and it's discovered these columns and with these data types. There's a date dimension, there is a product dimension, a customer, an employee, and a shipper. Now, for the purposes of migration, and particularly around data discovery, we're ignoring any views. So you can see on my fact table here, I have some role-playing date dimensions. We only want to move the date dimension once. We don't want to do it for each thing. So we're going to focus on physical tables and physical data at this point, and views as part of the subsequent steps. Okay, so now that I've discovered these guys, what I want to do is to say, profile the data. Now, why is it important to profile data if I'm just going to migrate the data? If I have a large table, multi-billion row table, I cannot just do a simple extract from source table, push into Snowflake table. If you try and do that in one transaction, it's something's going to fail. You're going to drop a packet on the network push to the cloud, something like that, and it's just too big to do as one transaction. So what we want to do is we want to look at a large table, and we want to say, break it into chunks, break it into ranges. And so because this is about automation, we want to automatically look at the columns in that table and look at the data in those columns and say, find me a good candidate, which might be a driver for being for ranging the data. And so we put in a bunch of heuristics, and it does depend on the source system for how we pick that. So for example, if I'm looking on Teradata, if a column in Teradata is tagged as the primary index, it would be an excellent candidate to range data on. And if I'm looking at Oracle, I'll be looking at different things. So I've discovered my data. Now we're going to profile it. So now we'll profile our nice small schema here. It's running a bunch of queries. It's looking for things like uniqueness. It's looking for things like average row length of the table and things like that, because part of the configuration of this is to say how big a bytes do I want to move to Snowflake at one time. So we would configure that. I think by default I've set that to be 100 megabytes, which I think is an AWS recommended standard. And so it's looking at the data in a table. It's saying, what's the average row length? Let's find a good candidate for ranging, and then let's come up with a set of ranges. Now it's only going to do that on those tables that it considers to be large. And again, you'd configure that to say, what does large look like? So this hopefully will only take a second to finish profiling my data. And then I'm running all of this on a virtual machine on my laptop, so the performance is not what you would see if you were running it on your server on your normal data warehouse database. Okay, and we could look at some of these tables here. You can see here that I've got a just under 3 million rows in my fact table here with an average row length of 208 bytes. And so on my smaller tables here, you'll see that I've, what have we got here? Row counts, 650 rows. It's nice and small, so we probably wouldn't create a range table. And we can look at the profiling results for each table if we wanted to. Profiling results, we can view that graphically perhaps. And we can see here we're looking for distinct value counts, and it looks like on my fact table here there's really only one column that has distinct values of any significant order, and that happens to be my order ID. Okay, we've discovered the data, we've profiled it. Now what we're going to do is we're now going to convert this into a Snowflake design, which in where are we? Advanced copy, here we go. Advanced copy into a WhereScape Red design, which will be a Snowflake design, Snowflake warehouse. We'll call it version number 1. And what this is doing is it's going to apply a set of what we call model conversion rules. And this will go through and it will say, look at the data types, the SQL Server data types, and come up with the equivalent Snowflake data type. So SQL Server has a money data type, Snowflake does not. And so it'll convert that to probably a numeric data type. Other things it's doing as part of the conversion, it's also looking at applying those rules to say come up with the range tables and things like that. So when we talk about design automation, this is applying, we've defined the rules once, and it's now applying this to, in this case, 6 tables, but nothing's stopping it being 6,000 tables. Okay, so we've generated our Snowflake equivalent, and you'll see when I display the little diagram here, you'll see that I've now got Snowflake data types there. And interestingly enough, I now have 7 tables. I've got this extra table called range fact sales detail. And what's happened here is it said, hey, I've recognized the fact table is a large table, like a monster table. We need to break that into ranges or batches so that I can, when I start to move the data, I can move that in smaller pieces. So we've determined that in this case, it's actually going to use the order date. It looks like it was the choice that it found to be the most appropriate. And so it's generated the range table. Okay, so that's the pre-work, the design, the discovery, the conversion to Snowflake. What I'm going to do now is push this whole design into WhereScape Red. So now, before I do that, we'll just have a quick look at WhereScape Red, and you'll see I have no Migration Express objects here. So this is empty, and we'll also check in my Snowflake world, in my database here, migrate MTO1. Let's do a quick refresh of that, and you'll see that there's no tables there either. Okay, so now we'll start our push to WhereScape Red. Okay, we've already determined that it's going to be a Snowflake design, so we don't need to convert it. And what we're doing here is we're creating a metadata packet. So this metadata packet is going to get pushed into the WhereScape Red metadata repository, and it's going to create the Snowflake tables. So it's going to create 7 new objects. We're happy with that. And it's going to go off and create me the physical structures in Snowflake for these new tables. Okay, we're partway through here. And one more, there we go. Okay, we've moved the metadata across. If I look in Snowflake now, I should see, here we go, here's my tables, they're all created, but as you can see here, there's no data. Right, in WhereScape Red, I'll just refresh my display here, And we should now see, there we go, there's my new Snowflake tables. So that was the first step, creating the Snowflake equivalent physical structures. The second step is to create the scripts to populate data. So pull the data from SQL Server to push into Snowflake. So we're going to generate all of the loading scripts. And so again, I've just highlighted all of these and said create. It's 7 tables. It could just as easily be 7,000 tables. It's a little slow because of my laptop and the network I'm on, but yeah, you'll
Michael,
see.
Under the covers here, we're generating, how is it generating the scripts? Tell us about what actually is being used to generate the scripts.
Right, yeah, so we have templates built into WhereScape Red, which look at the structure of the table, and it's looking at connections that we have created here. So I've got a connection off to my SQL Server legacy warehouse here, and so it's saying, okay, what are the steps that I need to do to get data from SQL Server? So it's creating, in this case, it's creating a PowerShell script, and its first step is a select statement from my SQL Server table, and it's dropping that into a file. It's then gzipping the file using Snowflake put to put that gzip file up into the Snowflake staging area. Then it's going to use a Snowflake copy to copy that into Snowflake. And it's using our template to come up with the pattern, or it has the pattern. It's now applying that pattern to all of these tables. Okay, so I now have. Sorry, Jonathan, you were going to add some color commentary there.
Good stuff. That we did it for 7 tables. Could have been 7,000, right?
Yeah, exactly. Yeah. So even though I'm showing you a small subset here, that is just for the purpose of demonstration. When you do this in anger, I have a project on Monday I'm starting, which has 9,000 tables. Jonathan's just finished one in Dallas. How many tables was in that migration project?
Well, I think for the POC, we loaded a couple hundred in a day or so, and we're now working on planning the migration of several thousand.
Yeah, so yeah, this is industrial technology for industrial size warehouses. Okay, so now I have the scripts created and the table created. The next step is, okay, what about running that? And so we could either run that individually, table by table, or we could create a job which would populate all these guys together. So let me just so if we look at now, I'm not sure how it's going to perform for loading, but we'll see how it goes. So I could load one table, and we'll just see what comes back with that. It's going to execute this PowerShell script connecting to my SQL Server database, and then it's going to move it to a file and then move it up to Snowflake. You would never run this one by one, and in reality, you might do it for the first one. Normally what you'd do is the job that we would create with this would run all 10,000 tables in a series of threaded jobs. So you might run 10 at a time or something like that. Okay. This is taking him, there we go. Okay, so we've now run the script. If I go and look in Snowflake here, and you'll now see that my dim product table now has 650 rows. So we've now populated that one table. Perhaps what we might do now is we might look, so let's talk about the range table quickly before I go too much further. So for the fact table, we've created this structure which becomes like a control table for loading the range table, loading the fact table. And so it's going to give me a minimum and maximum value for each batch, how many rows it expects to see, the start and end times for each of the steps, and then an actual number of rows that we can do audit checks to say, did we load everything we expected to, and then some stats around how long each step it took individually. So for the large tables, particularly multi-billion record tables, you don't want to have to write all of those controls around did everything load, is the data the same as it was in the source, all of that validation stuff. So we've built that into the process here. And so we could, just for excitement, the job I've just created here, migrating my legacy warehouse, you'll see all of my structures there. And so I could actually start this job, and we'll just have it running in the background while we keep talking here. Just confirm my scheduler is running. My scheduler is running, it is good. Okay, the job's now running, and you'll see I've got multiple threads will start to run together. Here we go, so now multiple threads are running together. Okay, so that was the first part of Jonathan's picture. You saw the lift and shift. How do I move the physical structures from, in my case, SQL Server into Snowflake? And then how do I go about the process of moving that data? So you've seen me in probably in about 15 minutes there. We've taken just 6 tables, and we've done that. If you were doing this manually, most people tell me, you know, my best guy, each table might take him a minimum of 2 to 3 hours. You scale that up, and your savings and human effort to move a warehouse becomes, you can see the value of automation there. So that's step 1, lift and shift. What about the step 2, the rebuilding of the data pipelines? We're not going to go into detail of what a demo of how that would look today, but perhaps what I'll do is this diagram we had up on the screen before. Let me talk through that in a little more detail. So this is the WhereScape Red architecture overview diagram. And so what we'd do is this is not migration anymore. This is redoing the data pipelines from my original source of my data to populate Snowflake on a daily incremental basis to keep my Snowflake data warehouse in sync for my users from original source. So we would connect to original data source, which might be your classic OLTP systems. You know, maybe it's an ERP like maybe Oracle Financials or Workday, or maybe it's just a relational database like some SQL Server database. Maybe it's files of a variety of forms. Maybe it's delimited. Maybe it's JSON files. Maybe it's a web service. Whatever your data sources are. And then to bring it into Snowflake, we will generate the script to do that along the same sort of lines as we talked about before. A query against the source, dropping it to a file, using the Snowflake put and copy commands to get it into the Snowflake world and onto the Snowflake database. This could be a full refresh or a delta. And again, you the developer decide object by object. From there, you ask the question, what does your data foundation layer look like? Is it a classic ODS? Are you a data vault company? And again, these are personal preferences. You choose the style you like. Maybe you're a very traditional third normal form kind of data warehousing people. So whichever style you like. And to get from our raw data into our foundation structure, we will transform the data by generating a Snowflake staging table, Snowflake code block to do the transform, and then again another Snowflake code block to publish, merge into our foundation layer. From there, you can look out to your star schema or your end user layer, which most classically is a star schema, but doesn't have to be. There are other models. And again, we'll generate the star schema physical layer for you and code to apply the transforms where you put in your business rules. Some people just than instantiating the physical tables. You guys will determine that site by site, customer by customer. You'll decide what works best for you. So all of your database views get built out as well. So this metadata and also to run the thing every day. So you should have the ability, after you've rebuilt your data pipelines, for an end user to say, this number, how did you derive that, and show the full lineage of that calculation. An auditor can say, this piece of code, this table, how did it arrive in production, who put it there and when and why. So yeah, that's what the metadata gives you with this. The key is that everything is generated along the way. So you typically, if you're writing this stuff by hand, and a lot of the cloud databases do not have good tools to allow you to do this well, we're probably going to save you anything from about 4 to 10 times the amount of time to do the development, let alone the ongoing maintenance, change management and documentation. Okay, let's have a very quick look at our job and see how it's doing. And we're down to the final step on the fact table. So you'll see we're capturing very rich metadata here. So start and end times, and the first one here, which was the customer dimension, we've got a very detailed log here. We brought across 533 rows, we loaded them, there was no indexes to build, etc. Let's look at our range table here. In fact, let's look at the range table from within WhereScape Red here. Display data, and this will, okay, sort by batch number. And you'll see here we've got 10 batches, and it looks like we've completed all but the very last batch, and that one's still running. And we've got some start and end times, we've got some row counts here, and other metrics over here about how long it took and whether it validated, etc. And if I look in Snowflake, we'll now see that my Snowflake data warehouse is now being populated. There we go. My fact table's got almost 3 million. In fact, the job's probably finished now, as well as these other counts. So that's a crash course in Migration Express using WhereScape to move a legacy warehouse into the Snowflake world.
Thank you, Michael. That was awesome to see just how quickly you were able to do that. So let's see. I am going to take back control, and we'll wrap up the presentation here. All right. So we saw the Migration Express demo. Before we move to questions, I want to first off thank you for your time and your willingness to listen to this topic today. We've got a few webinar takeaways. I think for different folks that are at different stages of kind of their BI journey and their data warehouse journey. For those who are considering or planning a data warehouse migration to Snowflake, Michael, what would next steps be around understanding Migration Express there?
Yeah, I would certainly encourage everybody to have a conversation with ourselves or Teknion. We do not have a large professional services team ourselves, so we rely very heavily on Teknion to do these for us. We have a great degree of trust in Teknion over the years with many successful projects. So I would say if you're considering or planning a data warehouse migration, come and talk to us. Firstly, is Snowflake the right choice? And secondly, in your world, what are the things that you're going to have to consider to move your particular environment across?
So I think there's probably another set of people in the audience, and there's those who are either already using a cloud data warehouse or who are already using another form of data warehouse that's not yet in the cloud, but either one, they want to look at kind of future-proofing their data warehouse architecture for the cloud or optimizing it for the cloud, as the case may be. Michael, you showed us a little bit about Red and 3D and kind of how those can apply. What do you think folks should be considering for if they're wanting to future-proof their data warehouse?
Yeah, anybody who's done a data warehouse with any level of maturity knows the thing that kills them is change management. And so, how do it's all right building my first version today, I could do that manually or whatever, but when I have to come to make changes next year, next 6 months, how do I, to future-proof it, I need to be able to document it, I need to be able to have good metadata around what I've built. And so the question you want to be asking here is, how do I bring a metadata-based automation tool into my data warehouse world? And so that's, again, you would come and talk to us about that and consider using the WhereScape products to bring automation into your world.
So thank you, Michael. That was good. And so for the final type of people, I think those who are just planning or looking into what should that cloud strategy be and not necessarily even at the point of planning a data warehouse project or migration. I just put a plug in. One of the things that we here at Teknion do for many customers is we start them off on their journey with BI or with data, and we help them out with a roadmap. Come in and understand, where are you? we're in the industry evaluating new tools, new products, things like Snowflake that are really taking the industry by storm. We have familiarity with those, and we can really help you understand, is this something that is going to fit into your strategy and where you want to be as an organization and your leveraging of data to drive better insights for your company. So we would love to help you out with that kind of a roadmap if that made sense. So feel free to reach out to us. I will leave my contact information here on the screen in case you want to. That's my cell phone. You can text me, call me, anything. I'm happy to answer questions or reach out via email. And would love to have a follow-on conversation about any of the topics covered today, whether it's Migration Express and how that might fit into your cloud migration, or WhereScape for just standard data warehouse automation, or maybe it's migrating your BI reports and needs over to a new platform. Any one of those, or a strategy conversation, we'd love to talk about that with you. With that being said, want to once again thank you for joining, and we've got a couple of questions I think that are coming in. So if you have your question that you would like to have answered, please go ahead and share that, and we can answer them. So Michael, we've got a question here. Along with tables, can you also migrate over views and stored procedures with Migration Express? So
yeah,
I think very good. Really great question.
Very good question. Let's start with views. So the thing with views is that if it's a simple one-to-one view, that's easy enough to do. The problem with views is that typically people put a lot of logic into them. There's unusual, more complex join conditions. Those are very hard to reverse engineer, particularly as the way a view is stored in the system catalog of the source database is not consistent across databases. And so what we do is we say we have a semi-automatic way to move the views. So we just need a human to check over it to say what is happening with this view, and then use the WhereScape Red to then automatically create that view using a drag and drop approach. Similar thing with stored procedures. So again, a human being wrote it. Reverse engineering stored procedures is the current hot topic in migration world at the moment. There are people who are trying to use AI to be able to figure this through. Basically, the short answer is it's very difficult. A human will still need to look at the stored proc to say what is going on, but then you don't have to rewrite that into Snowflake by hand. What you do is use WhereScape to automatically generate the Snowflake code block. Snowflake doesn't do stored procs, they do code blocks. So generate the Snowflake code block, but you still need a human to understand it. So I call that a semi-automatic migration as opposed to an automatic migration like you saw with the data and table structures.
All right, do we have any more questions? We'd love to hear from you. If you can either type them in or raise your hand. I think this is a great topic, and there's lots of interesting questions that you may have.
And Joshua, I think that was your question, so feel free to, if I didn't quite answer it, shoot us some more comments there, and we'll take that discussion further. Okay, after a table is...
Go ahead, Michael, you got it.
Yeah, after a table is migrated, how is the table kept up to date? Well, the question then becomes, how do you wish to keep it up to date? Do you wish to keep it in sync with your legacy warehouse? So do I want to still maintain my SQL Server data warehouse as my primary source and keep my Snowflake in sync with that? Or do I want to keep it up to date from the original source? So in effect, rewrite the data pipeline. So yeah, those are two options. Migration Express will do the incremental from SQL Server, from my legacy warehouse. And of course, the ultimate goal for you is to turn off your legacy warehouse in most cases. So you would rewrite your data pipeline in WhereScape Red, which would, like I showed in that diagram, connect to your source, bring the data across in an incremental manner, generate Snowflake code blocks to do ELT transformations into your database structures.
And Michael, if I might add on that topic, I think it's a great one that fits into kind of that anatomy of a migration project, right? And so once we can use Migration Express to lift and shift the data, we can keep it in sync also, which means that as we look at kind of that migration of BI tool connectivity to Snowflake, that can really begin to quickly shift load and cost and effort off of my legacy data warehouse. And so we can very quickly take advantage of the value of things like concurrency that can be much higher in Snowflake and things like that. So we can really improve the experience of the end user very quickly without necessarily having accomplished all of the behind the scenes rewrite, as we just keep tables in sync. And then behind the scenes, we can go ahead and take on the project of re-engineering or re-architecting the data pipeline. So we have another question coming in here. Do incremental updates rely on a column within the table to identify that the data has changed? And that, Michael, it is the case. This is not a CDC setup where we're reading logs, but it would be typically something like a date changed, element that would look at, either, new records entered with a create date or an update date, those kinds of things, and then applying those to the table in Snowflake. And then also, depending on size of tables and things like that, some tables we might do a full copy during the phase where we were, kind of using Migration Express to keep them in sync.
Correct, yeah. And so in effect, for those of you who are more deeply technical, ultimately we're going to be generating a Snowflake merge statement. When you do merge, you have to be able to identify what column determines uniqueness, and therefore how do I know whether it's an update or a change? As Jonathan said, it's not CDC. You can apply CDC, particularly if you're trying to keep a if I've got a SQL Server warehouse, I want that to be my primary driver, and I'm just keeping my Snowflake one in sync with that. We do actually have a WhereScape streaming product, which uses StreamSets technology, which can look at the for some databases. So SQL and Oracle are good examples. We can look at the logs and use that for just replication. But in most cases, that's not where people are looking at. They're actually looking at being able to maintain, turn off a legacy warehouse and pull directly from source.
All right, well, Michael, I think those were some really good questions. Thank you for your time, for participating in the call. Thanks to everyone who attended. We will have the recording loaded up on our website soon. So if you're interested in coming back and taking a look at any of this, or understanding more about that, again, don't hesitate to reach out, and we would love to hear from you. So thanks and goodbye.